All right, so here's an example. So solve each by using the quadratic formula. And so here's our quadratic formula, right? And and remember, I want you to keep in mind this is the discriminant, what's underneath the radical, and we'll kind of talk about that as we go, and then we'll generalize and draw some conclusions from what we find happens with the discriminant and what our final answers are. Okay, so the first thing when you're using the quadratic formula is set one side equal to 0, just like with factoring, right? So we're going to set one side equal to 0. So that's already done for us. Then you want to identify A, B, and C, right? Just like we've done before in different situations. So here A is 1, right? B is negative 11, and include the signs with it. You don't include the x's. You don't plug x's into the formula, just the coefficients, but do include the signs that go with them, okay? So B is negative 11 and C is negative 26, okay? All right, so now we're going to plug into this formula here. So what I like to do is make a little shell, and we did this before with different formulas, but and I think when we evaluated functions, we did some of this. Anyway, so I just make a shell and open up parentheses for each of the variables in here, right? So this is B goes here, B goes here, A goes here, C goes here, and A goes here, right? So I just kind of remember those things, and then we just plug them in where they go. So we plug in negative 11 for B. We plug in negative 11 here for B again. A is 1, C is negative 26, and A is 1 again, right? So that's basically how we set it up. And then from there, we're just going to do some PEMDAS, right? So negative, negative, that becomes a positive. So I'm just going to bring down positive 11 right here, plus or minus. And I'm going to do what's inside the parentheses here. And you can plug that whole thing in your calculator if you want to. So 11 squared, we'll kind of do some mental math here up here on the top. So 11 squared is 121, and then negative 4 times 1 is negative 4. Negative 4 times negative 26 is positive 104. So this actually becomes a positive 104, okay? So then 121 plus 104 is 225, right? So we take the square root of 225 and we get 15, okay? All right, so just to pause here for a second, that 225, the value underneath there, that was the discriminant, okay? And notice how it was a perfect square, so we came out to a whole number there, right? When we took the square root, and it was positive, and so keep that in mind as we go. So on the bottom, we get 2 times 1 is 2. All right, so we're almost there. Now we just have to evaluate the numerator. And remember, there's two answers because we have a plus or minus. So we're going to do 11 plus 15. And you don't have this green here. You don't have to show this work. You can go straight to the answers from here. So I have 11 plus 15, which is 26, divided by 2 is 13. And then here I have 11 minus 15, which is negative 4, divided by 2, which is negative 2. Okay, so there are two solutions. All right, so here we have two solutions. They're both rational. They're real, of course. And so that's what happens when we have a positive value for B and a perfect square, is we end up with rational real. Okay. All right. And once again, we'll kind of summarize and come back to that. All right, let's take a look at number 2. So I'm going to start by setting one side equal to 0, identifying A, B, and C. A is 20, B is 7, and C is negative 3. So now I'm going to set up this shell. And you can do it, whatever way you like the best. This just kind of works for me, is just to set up this template every time. Then I just plug in as we go. So I'm going to put in B, goes in the first couple spots. So 7, 7. A is 20. So A goes there and A goes there. And then C is negative 3. So that goes there. All right. And so now we can do our PEMDAS. So first of all, we don't have a negative, we just have a -7. So I'm going to bring that down, plus or minus. Now let's evaluate what's inside here, right? So I'm going to do 7 squared is 49. -4 times 20 is -80. -80 times -3 is positive 240. Okay, and so then 49 plus 240 is going to be 289. And if we take the square root of that, we get 17. So another positive and perfect square, right? So 2 times 20 is 40. Excuse me. 2 times 20 is 40. And then we're going to break this up into 2 with the plus or minus there, right? So it's going to be -7 plus 17 divided by 40. Or -17, or excuse me, -7 minus 17 over 40. All right, so for this one, -7 plus 17 is positive 10 over 40, which comes out to 1/4. All right, and if we do the other one, we get -24 over 40, which reduces to -3/5. Okay. All right. So those are our two answers. So that's how we use the quadratic formula. It's pretty straightforward, right? You don't have to think about it too much. You just have to, once you get one side equal to 0, identify A, B, and C, plug them in, and then just kind of work it out and see what happens, right? And we notice, once again, when the discriminant's positive and a perfect square, we end up with 2 real and rational roots.